Interpolate unstructured x, y, z data on best grid based on nearest neighbor distance for each points. This question was edited after answers for show final solution I used. I have unstructured 2D datasets coming from different sources, like by example. These datasets are 3 numpy.array, x, y coordinates and z value. My final aim is to interpolate these datas on a grid for conversion to image/matrix. So, I need to find the best grid for interpolate these datas. And, for this I need to find the best x and y step between pixels of that grid. Determinate step based on Euclidean distance between points. Use the mean of Euclidean distances between each point and its nearest neighbor. Use tree/tree from scipy.spatial for build tree of the x, y datas. Use the query method with k equals 2 for get the distances. If k equals 1, distances are only 0 because query for each point found itself. Performance tweaking. Use of scipy.spatial.tree and not scipy.spatial.tree because it is really faster. Use balanced_tree equals false with scipy.spatial.tree, big speed up in my case, but may not be true for all data. Use n_jobs equals 1 with tree.query for use multi-threading. Use p equals 1 with tree.query for use Manhattan distance in place of Euclidean distance. P equals 2, faster but may be less accurate. Query the distance for only a random subsample of points, big speed up with large datasets, but may be less accurate and less repeatable. Interpolate points on grid. Interpolate dataset points on grid using the calculated step. Set nan if pixel too far from initials points. Set nan to pixels from grid that are too far, distance, step, from points from initial x, y, z data. The previous generated tree is used.
I suggest you to go with ktree.query. You are searching of a characteristic distance to scale your binning. I suggest you to take only a random subset of your points, and to use the Manhattan distance, because ktree.query is very slow, and yet it is a log in complexity. Here is my code. I suggest you to use the Manhattan distance, this URL, because it was faster to compute than the Euclidean distance. And since you need only an estimator of the average distance, it should be sufficient.
The problem you want to solve is called the all nearest neighbors problem. See this article for example, this URL. I believe solutions to this are on log n, so on the same order as ktree.query, but in practice much faster than a bunch of separate queries. I'm sorry, I don't know of a Python implementation of this.
If you want to see more, please consider subscribing.